Today we're going to take all of this information that we've learned about trig and SOHCAHTOA, and we're going to apply them using word problems and real-world applications. Now remember that this is the only way that we can relate the side lengths of a triangle to the angles, besides using special right triangles, but we're talking about just right triangles with non-special acute angles. That means, like if they have a 37-degree angle instead of a 30-degree angle. So we're going to look at those, and there's a few things that I want you to remember. Now, you're going to probably want to stop the video to keep up with the notes, and remember that you can rewind and re-listen, and that's what you should be doing in the process of learning in the flipped classroom. So the first thing that I want you to remember is that these are all right triangles. So draw right triangles on each one of them. And label everything. The next thing that I want you to remember is we're still going to use SOHCAHTOA. And I want you to remember that if you have a missing angle, so if the problem's looking for the angle, you have to use the inverse functions. Sine inverse, cosine inverse, tangent inverse, which they're written with the little -1 exponent, but that's what we use to show that something's an inverse. So for missing angles, or I could say to find the angles, we use the inverses. So sine inverse, cosine inverse, tangent inverse. I'm still going to set up the opposite over hypotenuse or adjacent over hypotenuse, or the opposite over the adjacent. But when I put it in the calculator, I'm going to use the sine inverse and then put the opposite over hypotenuse fraction in. And remember that we want to round to the whole number. We want to round to the nearest degree. I want all angles to be whole numbers. Okay, so now to find the missing sides, because that's what you should have learned last night, is how to find the missing side. So to find the missing side, we're still going to use SOHCAHTOA, but we're going to have to set up an equation, and then remember, we're always going to multiply by whatever the denominator of the fraction, the opposite hypotenuse, adjacent hypotenuse, opposite adjacent, whatever fraction we have, whatever that denominator is, we're going to multiply by that. Sometimes we end up still having to go one more step to solve for x by dividing, and sometimes we don't. It just depends on what the denominator of that fraction is. If the denominator of that fraction is a number, then it's just a one step. But if the denominator of that fraction is an x, then when I multiply across by x, I'm going to have x times something. And we'll see another example of that, but you did learn that last night. So for missing sides, we set up SOHCAHTOA and multiply by the denominator. Whatever the denominator is. Okay, so at some point you may need to have stopped this or rewound so you can write all this, because I'm going to move on to my first word problem example. And you may want to draw a right triangle before you even read the problem. I'm going to read the problem, then draw the right triangle on this first one, but then the next one I'll draw a right triangle and then read the problem. It really doesn't matter. They're all going to be right triangles. All right. A boy flying a kite lets out 200 feet of string, which makes a 42-degree angle with the ground. Assuming that the string is straight, how high above the ground is the kite? Okay, so I'm going to draw a right triangle. I'm not drawing a boy and I'm not drawing a kite because we know I can't draw. I can't even draw a right angle. Okay, so let's talk about it. It says a boy flying a kite lets out 200 feet of string. Well, this isn't the string, this is the ground. My kite's here. The boy holding the string is here. So the 200 feet of string is the hypotenuse. It says, which makes a 42-degree angle with the ground. This is the ground. This is not the ground. This is the ground, so the 42-degree angle is here. Assuming that the string is straight, how high above the ground is the kite? So they want to know this distance here, that's my x. And I have to figure out, is that opposite of my angle or is that adjacent to my angle? Remember, opposite means across from. So it is opposite. Opposite and hypotenuse is my sine, because sine is the so. This is what I know. Sine of 42 degrees equals the opposite, which is my unknown, my x, over my hypotenuse, which is 200. Sine of 42 degrees is opposite over hypotenuse. How did I know that? Because that's what's labeled on my triangle, the opposite and the hypotenuse. So I'm solving for a side length. I'm going to multiply by the denominator. So I'm going to go 200 times the sine of 42 equals x. Luckily for me and luckily for you, the x is already alone, so I don't have to do anything else other than put this directly in my calculator. Am I looking for an angle? No, I'm not looking for an angle, so I'm not using an inverse. I'm typing in exactly what I see. Okay, so let me see if I can darken my screen just a little bit for you. All right, 200 times the sine of 42. And this is a side length. So with side lengths, I've told you guys I want you to go to 1 decimal place. So this is going to be 133 and 8 tenths. So 133.8. And it's feet. So set up your triangle, make sure you label everything correctly, and then figure out what you have. Do you have opposite, adjacent, hypotenuse? Do you have an angle? From that, you know what to do. If you're looking for an angle, then you know you're going to do an inverse operation. But we weren't looking for an angle. We were looking for a side length, so we were good to go. All right, let's try another one. All right, I'm going to just draw a right triangle. I know it's going to be a right triangle, so I might as well just draw it. Okay. A straight road to the top of a hill is 3,000 feet long and makes an angle of 12 degrees with the horizontal. Find the height of the hill. Okay, let's talk about it. A straight road to the top of a hill. This would not be a road to a hill, top of a hill. This would be a road to top of a hill. I can't drive a car up this, but I can drive a car up this. So this is where my 3,000 feet is going to go. Makes an angle of 12 degrees with the horizontal. Horizontal means left and right. This is not horizontal. This is horizontal. So the horizontal is this angle right here. That's 12 degrees. Find the height of the hill. Is this the height of the hill? Is this how tall the hill is? No. That's how long it takes the road to get there. Maybe not how long, but it's the vertical distance. This is the height of the hill. So that's what we're looking for. That's our x. That's the question. Okay, so let's talk about it. From the angle, x is opposite. 3,000 is hypotenuse. So opposite and hypotenuse is the sine, because that's the so in SOHCAHTOA. So let's set it up. The sine of 12 degrees equals the opposite, which is x, over the hypotenuse, which is 3,000. Sine of 12 equals opposite over hypotenuse. Since it is an equation, I'm going to multiply by the denominator. So 3,000 times the sine of 12 equals x. X is alone. Ta-da! All I have to do is multiply. So I'm going to type it in. 3,000 times the sine of 12. And it's side length, and I told you side lengths were going to round to one decimal place. So this is going to be 623.7. And it is feet. That's how high the hill is. That's the height of that hill. Okay, next one. Jonathan's flying a kite. The string makes an angle of 43 degrees with the ground. If Jonathan is standing 150 feet from a point on the ground directly below the kite, find the length of the kite string. I don't know. Let's draw a triangle. Let's see if we can figure something out. Jonathan's flying a kite. That didn't really help me. The kite string makes a 43-degree angle with the ground. This is the ground. There's 43 degrees. If Jonathan is standing, well, let's think about where Jonathan is. Is Jonathan here if the kite string's there? No. Here's Jonathan. That's Jonathan. I'm going to put a J. There's Jonathan. Here's my kite. Jonathan's holding the kite. So Jonathan is standing 150 feet from a point on the ground. The kite's not on the ground. This is a point on the ground directly below the kite. This is the point on the ground directly below the kite. So the 150 feet goes here. Find the length of the kite string. This is not the length of the kite string. This is how high up off the ground the kite is. This is the kite string. So this is what the question's asking about. So from this angle, we know this is hypotenuse and this is adjacent. Cosine uses adjacent over hypotenuse. So I'm going to go cosine of 43 degrees equals adjacent, which is 150, over hypotenuse, which is x. So since I have an equation, I'm going to multiply by the denominator. That's what I always do, multiply by the denominator. So x times the cosine of 43 equals 150. What's wrong? Can I do that? I can't multiply x times the cosine of 43. I'm solving for x. I'm trying to figure out what x is. So what I want to do now is I want to divide by the cosine of 43 so that I can get that x alone, so I can isolate it. So x equals 150 divided by the cosine of 43. I'm not looking for an angle. I'm looking for a side. And I'm saying that because you're not using an inverse unless you're looking for an angle. 150 divided by cosine 43. 205, let's look at it. 205.1. That's how long the string is. All right, one last one. A 15-foot ladder leans against a building. The ladder's base is 12 feet from the building. Find the angle at which the ladder makes with the ground. So let's draw a triangle. A 15-foot ladder leans against the building. This is the ladder leaning against the building, so it's 15 foot. The ladder's base, remember base means bottom, so here's the ladder's bottom. The ladder's base is 12 feet from the building, so this is 12 feet. Find the angle. So this one's asking for an angle. That means I'm going to use an inverse. If the question asks you to find an angle, you know you're going to use an inverse, one of the negative ones. Find the angle at which the ladder makes with the ground. This is the ground. This is the building. This is the angle it wants right here. So make sure you know the angle. So that's my angle. Well, from this angle, 15 is the hypotenuse. Hypotenuse never changes. 12 is adjacent. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. I'm looking for an angle, so I'm going to go cosine inverse. Adjacent over hypotenuse. Make sure you punch it in correctly or it's going to give you an error message. So I'm going to go cosine inverse 12 over 15, and it's an angle, so I want to the nearest degree. What would the nearest degree be? 37. Make sure you listen to the notes again if you need to. Make sure you took good notes. Write down any questions that you may have. Remember, these are right triangles we're talking about. You're still going to use SOHCAHTOA. Think about when you use the inverse and when you don't use the inverse. The only time you use the inverse is when you're looking for an angle. Remember, the inverse are the ones with the long negative 1. They're actually going backwards. Okay, hope this does you good.